So the purpose of this video is to get you to memorize your prefixes. It's actually in a series of 12 videos, it's number 9. Number 8, the previous video, was all about getting you to enter these 6 prefixes into your calculator, which is obviously a very important skill. You'll be seeing that again in this one. Now, before we get going, I'm going to just remind you again of the 6 prefixes that you need to remember, and the large ones first. We've got giga, capital G, times 10 to the power of 9. Then, of course, mega, which is times 10 to the power of 6. Kilo, times 10 to the power of 3. Then the smaller ones, milli, which is times 10 to the negative 3. Micro, which is times 10 to the negative 6. And nano, times 10 to the power of negative 9. Now, take a look at those just for a second. We are going to look at some example questions later involving these prefixes. But first thing I'm going to do is just to double check, just after I rearrange that piece of paper, just double check that you remember them. So let's have a look at them again. So just as an example, you'll see one coming up on screen. I guess at that point you can either write down the power of 10 or you can just shout it out. So micro, that is times 10 to the negative 6. Next up, we have got mega, which is of course times 10 to the power of 6. Next one, nano, of course that's the smallest one. Nano is of course times 10 to the power of negative 9. I gave you too much of a clue there. Number 3, kilo, is of course times 10 to the power of 3. Now, one thing that is worth remembering is that, of course, anytime you see kilo, in fact, 99% of the time where you see kilo, say kilovolts, you need to change that to volts. Kiloamps, you would need to change to amps. For mass, the unit of mass is actually the kilogram, so you don't actually have to change anything. There you go. Now, for the next one, number 4, we've got giga. Giga is, of course, times 10 to the power of 9. Of course, I remember the larger prefixes because I remember kilobytes, megabytes, and gigabytes. Gigabytes, of course, being more memory than a megabyte, and a megabyte being more than a kilobyte. Number 5, we've got milli, and this is the last one before we look at some example questions. Milli is, of course, times 10 to the power of negative 3. So, as I said, we now have 5 questions coming up where the prefixes are, of course, incorporated into the question. Let's have a look at them. Here's number 1. Now, if you don't know the equation, that's not an issue. I'm going to tell you the equation to use for each of these questions. The most important thing is just to remember that prefix. So, in the first one, we have a question that says, calculate the period of a wave, which is a frequency of 2.4 gigahertz. Now, the equation to use is period t is equal to 1 over frequency. Now, I guess I'll write this in a different colour, where frequency, now you wouldn't have to write this in, but frequency is 2.4 gigahertz, just to remind you. If I was substituting this value into this equation, I would of course write 1 over 2.4 times 10 to the power of, so what is the power associated with giga? Times 10 to the power of course it's times 10 to the power of 9. Now to enter that into the calculator, we would just do 1 divided by 2.4, then this button here down at the bottom, times 10 to the power of, and then 9 is equal to. So of course that's written as 4.166666 recurring times 10 to the negative 10. A important thing is there is another video which talks about how to actually write this in scientific notation and to an appropriate number of significant figures. I'll not cover that in this video. This is the important thing. So remember, it's one mark for the equation, 1 mark for the substitution, and of course the important thing here was we needed to remember that giga was times 10 to the power of 9, and then we would write our answer next. But I'm not going all the way through all of these questions. Here's question number 2, says calculate the frequency of red light with a wavelength of 650 nanometers. Now again, I'm going to tell you the equation, and it's V is equal to F times lambda, that's speed, is frequency times wavelength. And then I can rearrange that one to give me frequency is equal to V over lambda. Now, if you don't know what these three dots mean, that just means therefore. So if V is equal to F lambda, then F is equal to V over lambda. Again, there's another equation about rearranging, another video about rearranging equations. How I got from this equation to this one is I divided both sides by lambda to give me F on its own, and that's equal to V divided by lambda. If you're not 100% sure with rearranging equations, as I said, there is a video about that. Now, we're told in this question that V is 3.0 times 10 to the power of 8, and we're also told that lambda is 650 nanometers. Of course, that's meters per second. There we have it. Now, if I was substituting these two values into this equation, I would write 3.0 times 10 to the power of 8 divided by 650. But most importantly, what does nano signify? Of course, it's times 10 to the power of -9. So if we want, we could work that out as well, but I'll not write down the answer. 3.0 times 10 to the power of 8 divided by 650. Then I press the times 10 to the power of x button, then the negative button, then 9. So again, I'm just showing you up to the point of entering into the calculator. After this, of course, you would have to round this number to an appropriate number of significant figures. That would actually be 4.6 times 10 to times 10 to the 14. So 4.6 times 10 to the 14. And of course, that is a frequency and it's in hertz. Other important thing, of course, is to remember all of the appropriate symbols which are used in the equations, and of course the units. So frequency is measured in hertz. Now let's see number 3. Number 3, calculate the energy supplied in 1 minute by a 520 megawatt power station. So for this one, we're going to use the equation energy is power times time. And in this question, power is 520 megawatts and time, well, I mentioned, of course, the correct units and the correct symbols and so on. There is a video, in fact, where I talk about the correct symbols to use in the equations, and of course not just the correct symbols but the units as well. Really important to remember. And this is talking about time, and time should not be in minutes if it's written in minutes or hours or anything else. That should be changed to seconds. So of course 1 minute is 60 seconds. Now if I wanted to, of course, substitute these values into the equation, that would be power as 520 times 10 to the power of, we've got mega, which is of course 10 to the power of 6. We'd multiply that by 60. So that would give us 520, then the times 10 to the power of button, then 6 times 60, and that gives us that. 3.12 times 10 to the power of 10. Now, as I said, I'm not going to write down the answers in these questions. I'm just going to show you, I guess, up to the point of memorizing, or just recalling, I guess, in this case, recalling the prefix. So mega is times 10 to the power of 6. Next one, number 4. So number 4, we actually have two prefixes here. It says calculate the voltage across the resistor in the following circuit. So we're going to use Ohm's law. V is equal to I times R. And the two values that we're told are, again, you wouldn't have to write these down. I is 2.2 milliamps and R is equal to 4.7 kilo ohms. So if I had to substitute, then I would have current 2.2, whoops, get rid of that, 2.2 times 10 to the power of, well, it's milli, which is of course times 10 to the power of -3, multiplied by resistance, which is 4.7 times 10 to the power of, well, kilo is of course times 10 to the power of 3. There we have it. Now, talking about kilo, if we have resistance in kilo ohms, we have to change that to ohms. If we had kilo amps, we'd have to change that to amps. Kilovolts, you guessed it, we change it to volts. The one time we don't have to do that is with mass. So the unit of mass, what's called the SI unit of mass, is the kilogram. So in fact, if we get mass in any other units, if we get, say, mass in grams, we have to actually change that to kilograms. So if we're told the mass is 2 kilograms, we don't have to write 2 times 10 to the power of 3. The mass would just be 2. So 2 kilograms, the mass is just 2. Because that is the SI unit. Kilograms is the SI unit of mass. Now, to work at this answer, we just do 2.2, then this times 10 to the power of negative 3, multiplied by 4.7, and then of course the times 10 to the power of, and then 3, and that would give us this 517 over 50. We don't write fractions in physics. So we press the SD button and we get 10.34. Now we'd get away with writing 10.34. The only thing is, if you look at the two numbers in the question, this one is written to 2 significant figures, that one's written to 2 significant figures, so technically our final answer should be written to 2 significant figures. I don't know if you know this, but you would actually get away with writing 10.34. You'd actually get away with writing 10.3 because you're allowed writing anything up to 2 figures more than the number that you should be. So the rule is you write the final answer in the same number of significant figures as the number in the question with the least number of significant figures. In this question, that's 2. I'm going to go to the last question, and then I'm going to get you to see if you can recall the prefixes again. So this is number 5. Current in an electrical device is 25 microamps when the voltage across it is 73 kilovolts. Calculate the power dissipated in the device. So your equation to use is P is equal to IV. Now current I is equal to 25. You've got that one to remember, micro. And you have, of course, V is 73 kilovolts. So if you can try and remember, what does micro, of course, stand for, and what about kilo? So as I said, for kilograms, for mass, we don't have to change that, but this one we do have to change kilovolts to volts. So to substitute in, we would have our current 25 times 10 to the power of, so micro is, of course, negative 6. For this one here, voltage is 73 and kilo is times 10 to the power of 3. So to enter that into the calculator, we'd have 25 times 10 to the power of negative 6 times 73 times 10 to the power of 3. That would give us this again, no fractions in National 5 Physics, 73 over 40. We press the SD button and we get 1.825. Now again, both numbers here, 25 and 73 are written to 2 significant figures, so that should really be written as 2 significant figures as well. You know what? Since this is the last question, I'll write that in. 1.8 watts. Now, to finish off, we have the 6 prefixes again. I'm going to show you them quickly and see if you can remember them. And they're in a different order than they were before. So first off, we've got milli. Of course, that is times 10 to the power of negative 3. Second of all, nano. Nano is times 10 to the power of negative 9. Of course, we've got 6 to memorise in National 5 Physics. The third one is giga, one of the larger ones, remember, which is times 10 to the power of 9. Number 4, micro, times 10 to the power of negative 6. Number 5, we've got kilo, and we've spoken about the fact that, of course, mass should be kept in kilograms. Anything else, as I said, kilovolts change to volts, kiloamps change to amps, kilowatts change to watts, and so on. So kilo is times 10 to the power of 3. And the last one, is mega, which is times 10 to the power of 6. So that's just about us. I'll just show you one last time those 6 prefixes that you need to remember for National 5 Physics. Hopefully this has been some use for you. And we'll see you in the next one. Bye for now.